Today we're looking at the domain and range of continuous functions. So when writing the domain and range values of continuous functions, we use inequality notation. It's is not possible to list all of these values. So what we mean by that is because this is a line, I can't note and write down all of the decimal numbers in between here. So instead, what we use is we use an inequality notation. So remember, inequalities are either I want this will work. I want less than or greater than, or less than or equal to, or greater than or equal to. Remember, we close in our dots when it's less than or equal to or greater than or equal to. We keep our dots when we keep our dots open, it means less than or greater than. So remember, domain is the set of all x values. Remember, range is the set of all y values. So when we look at this for the domain, we look at what's the smallest x value. So I take my pencil, I put it on the dot, and I draw up until I hit the x-axis. That's -6. Okay? Is it included or not included? With an open circle, would I include it? No. So I write the less than symbol. Next, this x value. So we're saying the domain starts at -6 and it goes all the way here. And I draw a line going down. Remember, domain is left to right. So I draw a line all the way down. This is 1, 2, 3, 4, 5. And because this is a closed circle, we would say it starts at -6 and goes and includes 5. So all of these values between -6 and 5 all work, including 5. So what we're also saying there is you could pick any number you wanted between -6 and 5, and that would end up on this graph. It would end up on this line somewhere. Now, range is the set of all the y values. So when we say the smallest y value, we go all the way to the bottom of our graph. And again, I'm going to put my pen here and I'm going to draw a line. And it looks like it crosses at -6. And because my circle is open, I'm going to use the less than symbol. And I'm going to go up here to y, my top part, and I'm going to draw over. It looks like it crosses at 8. And because the dot is closed, I'm going to say less than or equal to. So we're saying our range values stretches from -6 to +8. These are all of our range values. And these are all of our domain values for this function. We pick any number right here in the red area and right here in the blue area, we would find a point somewhere that would land on this graph. Okay, so here's what I like to do first. I'm going to go through and find the domain for each one of these for problems 1 through 4. Okay. So for the domain, I draw a line going down. That's -8. I draw a line going up. That's 8. Because remember, domain is left to right. Because both my circles are open, that means I'm only using the less than symbol. For domain here, I start on the left side because remember, domain is left to right. So this is my first part of this graph. I'm going to draw a line that goes down. Looks like it hits -2. I'm going to draw a line down. It looks like it hits 6. On this side, the dot is closed, so that is less than or equal to. And on this side, the dot is open, so it is the less than symbol. In problem number 3, here's my first dot. It's on the left side. I draw a line that goes down. That's -5. I find this on the right side. It's 1. And if you notice, every single time, -8 to 8, -2 to 6, -5 to 1, it is always the smaller value on the left and the larger value on the right, because I am reading this from left to right. This one is included, so this is less than or equal to. This one is not included, so it is less than. Here's a strange one. This is one where it does not have a boundary. It only has a boundary on one side. So -8. So -8. And it's included. So less than or equal to x. And that's it. Because there's nothing stopping it over here, I don't write anything on the right side, the greater than side of x. On this one, this has an arrow that goes off in this direction and an arrow that goes off in this direction. It's still going to the left. It's still going to the right. So this goes out forever, left and right. So my domain is all real numbers. Here, this is a linear function. Again, it's going down and to the left, and this one's going up and to the right. So again, because this is stretching all the way in both directions, going to the left and going to the right, so it's going to the left, it's going to the right, my domain is all real numbers. There are no points stopping this. This one had a point that stopped it. It started right here, and then it went out. So there was a stopping point here. This one and this one, they don't have any stopping points. Okay? And I can't guess what the stopping point is going to be. If there was one, they would have to graph it for me in order to correctly identify its domain. But based on what they gave me, my domain is all real numbers for these last two. Okay, now let's practice my range. So remember, range is bottom to top. So my bottom part of the graph isn't over here, it's way over here. So I draw this over, this is -4. I draw this over, that's +4. Both of them have open circles, so both of them are less than and less than. Again, -4 is less than y is less than 4. That makes sense. Here, I need to find the bottom part of my graph. The bottom part of my graph is not here, and it's not here, it's all the way down here. And so when I draw this over, this is -7. And when I draw this over, this is 8 on both sides. So because this goes all the way down and touches the spot and then turns around, my range is -7 is less than or equal to, and up here at 8, I do include it. Though this circle's open, this one is closed, and so I do have a range value of 8. So it goes from -7 to 8. It is a smaller value going to a larger value. In problem number 3, again, bottom to top. My bottom part of my graph is 1. The top part of my graph looks like 9. The bottom part is open. The top part is closed. So it is 1 is less than y is less than or equal to 9. So this is the extent and the stretch of my range. And again, my domain would be this tight area from here to here. Number 4, my range value. This is my lowest point right here at -2. And it's included to my y value. So it's less than or equal to. And again, because of that, that's it. Because this is going up forever, as far as I know, with this line, with this arrow, because it's going up forever, my range is -2 is less than y. And that's it. It goes up forever. Here, number 5, my range right here is -2. That's my lowest value. But again, these arrows are going up forever. So unlike my domain, I do have a minimum value. It's -2. but I don't have a maximum value because it goes up forever. And on this linear function number 6, this is going down forever. This part is going up forever. So my range is all real numbers. And that's our notes for domain and range of continuous functions.